Hello everyone, this is Dr. Krishnan, Assistant Professor, St. Joseph College of Engineering. First, I would like to welcome our patrons, Dr. P. Bob Munagaran sir, Chairman, St. Joseph Group Institution, Mrs. Jessie Priya ma'am, Managing Director, Mr. Shashishekar sir, Director, Dr. Vadi Shashigiri Rao, Principal, Dr. Harvardin ma'am, Dean Research, Dr. V. Nandini Devi ma'am, Convener and Head of the Department of Science. And most importantly, I welcome all the participants for this 3 days faculty development program. Before commencing the session, a few words related to today's session. We are living at the start of third millennium of the common era, at the time when the boundaries between the known and unknown are shifting faster than they ever have before. Questions that seemed imponderable just a few decades ago are now all but settled, and many of today's biggest questions could not even have been imagined by our ancestors in centuries and millennium past. Of course, still we don't know why the universe exists in the first place or why we are here to ask such questions, and it's possible that we never will. But modern science offers satisfactory answers to many of the what and how questions that have puzzled humans for thousands of years. The biggest mystery of all dealt with Earth's place in the universe until Kepler and Galileo settled the matter some 400 years ago. Today, we know that Earth is in the third in the order of distance of 9 planets that orbit in the Sun. But in earlier, we know that Sun, according to geocentric theory, Earth at center, all the planets revolving on the Sun. But later on, it is realized Sun at center, uh, and all the planets revolving around the Sun, according to heliocentric theory. So, like this, there are so many mysteries in the universe. By this context, we hope the lecture by our invited speaker, Dr. Ebenezer Selaswamy Edwin, on mysteries in the universe will help the audience to acquire a clear picture in this particular domain. I'm really honored to be a part of this faculty development program and to give an introduction about the speaker. A good introduction is essential to get a speaker to a good start. It is uh, my immense pleasure. And Dr. Ebenezer Selaswamy Edwin, resident scientist, Kodaikanal Solar Observatory, Indian Institute of Astrophysics. He did his bachelor degree in physics at Adelphi College and master degree in physics from American College in the 1988 batch. After his MSc, he joined a project at Raman Research Institute, Indian Institute of Astrophysics, Bangalore. He became a student of Instrumentation Department at Indian Institute of Science, Bangalore in the year 1997. Later, he returned to astrophysics to build an instrumentation for radio astronomy group at Indian Institute of Astrophysics. He obtained his PhD from University of Mangalore. He served as a scientist at Indian Institute of Astrophysics, Bangalore, and held visiting position at the National Institute for Space Research, Brazil for 3 years. After that, now he is working as a head of Kodaikanal Solar Observatory. He is a member of Board of Graduate Studies at Carnegie University. He is having more than 21 years of experience and published a good number of research papers in well-reputed national and international journals. He has taught courses on solar, radio astronomy, and instrumentation. His research areas covers radio telescope, radio receiver system, radio spectrograph, radio emission, which is associated with the shock waves, and solar observations. And he has been awarded with many fellowships. In 2014, CNPQ fellowship by Brazil government. In 2013, CNPQ fellowship by National Institute of Space Science, Brazil. In 2011, FAPSP fellowship by Brazil government. With this short introductory, let me hand over the session to the speaker. Well, I welcome you, sir.
Thank you. Thank you. Okay. Dr. Krishnan, thank you for your liberal words of introduction.
Thank you so much, sir.
Thank you. I am as usual, like I would like to be very simple as I am, and I wanted to give the mysteries in the universe to the students listening to this lecture. Whenever we see anything, amazing things, like whenever you are seeing anything in the universe or whenever doing the observations, I'm basically an instrumentation engineer and turned into an astronomer. With my hands, I would like to do a lot of instruments. So that is my, you can say that is my hobby also. So I am very happy that a lot of engineers here and many people who can do some instruments and are associated with this lecture. I'm very happy for you. Whenever we see the universe, it is a mysterious one. Why I call that is a mysterious one? Because whenever we see it, we do not know or we cannot understand it. And later, many with the help of instruments and with the help of many other tools, theoretical tools, we try to understand. Then it will be the mystery will be revealed to us. Till that time, we used to puzzle about many things about the universe. Good. So when you look into the ancient Athens in the 400 BC, Plato told like this: astronomy compels the soul to look upwards and leads us from this world to another. And everybody started wondering about the universe, where we are, how we are, and all the stuff. Astronomy is the one field, it's one of the ancient field, I can say, that kindle the curiosity of a human. And humankind is instinctively curious about the world and where they are in their place. It drives, nowadays we have a lot of technological things like that aids us, like powerful telescopes and ground-based telescopes, space telescope, that gives a understanding about our universe. We are trying to understand about the universe. If you connect all the stars to some extent, we can get a constellation. That's what, that is a starting point of an astronomy. And we have, in the modern day, we have 88 constellations. Why constellations? That is the way we can identify a location. It's more like we are giving a different names to the places, Tiruchi, Chengalpattu, like we are giving a location. The constellation gives a location of the a different group of the stars in the sky. And astronomy, it is for all people, like irrespective of any discipline like arts or science or anything. Discovery change the people's perceptions. Generally astronomy is non-threatening science. People say like a virus, all the stuff. Now we know that COVID, it's a threatening science. And astronomy is more like some many people, they from every different walk of life, people take the astronomy club and they wanted to be enjoy that one. For those who want to study astronomy, sky is the limit. It inspires. Astronomy inspires everybody. People who are inspired can achieve more things and beyond them. Let me start with a small history of this place. And we have the history for this observatory from the year 1786. Now I am just going to take you through a tour, virtual tour, so that you will see different instruments. Variably, you will enjoy seeing this one. The way back in 1786, when Britishers wanted to come from the England or to Chennai, the only route is sea. So the flights was not on operation. People have not discovered flights. So only way they have to do the voyage, they have to do the ship travel for a long distance. When you go into the ship and 200 kilometers into the sea, when you see here and there, you won't see anything. Every direction look alike for you, except the sun will be rising and setting. And the sailors will be trained by the people to see the stars to find the directions. For that only, some of the people, William Hershey's and John Evershed or Michael Smith, and these people, they are not so happy with only training the sailors. They wanted to do some little bit science for that. So they identified, they initially landed up in Chennai and Nungambakam. We have this building there, I think. And from there, they have moved to the new place called the astronomy. They moved to Kodaikanal. We have the history for this place from the year 1890 or so. They have started constructing the telescope sites and everything. The Kodaikanal Palani Hills, they have constructed the huge place. Then it's a huge area and part of the forest department, and it's a very beautiful place, Kodaikanal. In this place, on the highest mountain, highest peak, 2,343 meters, it's the highest peak. There we have settled down and we have put these telescopes here. And we have the hydrogen alpha telescope, which is at 6562 Armstrong unit. Then which got the most abundant gas in the hydrogen, the solar atmosphere, it is hydrogen, as you all know that. So the wavelength, which is corresponding to a Balmer series, that is 6562. It will be, we can see about the lower chromosphere of the sun, and we can study about a network and internetwork, and we can see about the filaments and different features on the sun using this fantastic telescope. And Kodaikanal Solar Observatory, we have twin telescopes. One is at 6-inch telescope, another one is an 8-inch telescope. The 6-inch telescope from the year 1904, we have a record of all the very beautiful records of the sun. And nowhere in the world, people in 1960s or late 60s, 70s, they have built a good telescope anywhere in the part of the world, but they do not have the rich collection of the data. So we, from our data, we could identify that the sun is behaving periodic pattern. We call that as a solar sunspot cycle. Every 11.2 years, the sunspot goes maximum and come to the minimum. With the Kodaikanal Solar Observatory data, this is a historical 6-inch telescope, and you are seeing another 8-inch telescope. We are now using it for the night sky observation. Night sky observation, N.R. Pogson from the year 1836 to 1880, or almost more than 30 long years, he worked to make a very beautiful sky atlas. I think that is one of the first atlas which ever people have made from the Asia Pacific region. And he identified 60,000 stars, N.R. Pogson. And he hardly worked, and he made a star catalog. And he used this kind of a telescope. You are seeing this telescope. The next beautiful telescope we have is a tunnel telescope. That's 62 centimeter huge mirror we have. That mirror is a 3-mirror system that will produce a spectroscopy. And physics people may be knowing about spectroscopy. The spectroscopy will be very useful to study about spectral line. And when a star goes away from you or coming near to you, we'll be getting a red shift and blue shifts. We can measure the Doppler shift using this telescope. It is very useful. And this is another aerial view of this telescope. Very recently, almost some 8 years back, we modernized our observations with this telescope. That is called, we call that as a WARM telescope, White Light Active Region Monitor telescope. That produces on the back end, you can see the optics here. See, astronomy and optics, both the things will go together all the time. So, as a good astronomers are good photographers also. So, those who are having the flavor for photography, definitely they will like the astronomy, the part of the astronomy. We have the beam splitter mirror here, beam splitter that will go into the 2 different wavelengths. We can measure about the white light as well as the calcium K, 39, 33 Armstrong we can measure with this one. Very beautiful telescopes. Next one, historically we have used this one. Now presently we could not get the photographic film for this. Therefore, this telescope is unused. But we can use this telescope also for imaging purpose. And the back end of that telescope, you can see a beautiful image of the sun at the back end. Can you see that one? Here we can see about the, there will be a small variations, or there will be a small atmospheric turbulence at the edges of the sun. We can see this with this telescope. Recently, we have put a radio polarimeter, and that works with a 30 to 430 megahertz. Basically, I'm a radio astronomer. So I have put a radio telescope here. This radio telescope can view the sun at radio wavelengths. I don't want to go into the detail about it, but it gives it is an unseen universe. I'm going to tell about it. There's a person by the name called John Evershed in the year January 5th, 1909. He discovered from the sunspot, he is John Evershed, and he took some of the eclipse experiments with the people. So he was extensively worked with the sunspots. He found that there is a flow of gases from the sunspot. If somebody has any questions, you can, I pass a while. You can post your questions also. I can read it and I can answer it. Sunspots are relatively cooler regions on the sun. Why I say cooler? Cooler means we cannot go and touch it. It is not that way. The magnetic field, intense magnetic field is there. Therefore, radiation cannot enter in or escape out. Therefore, relatively, it looks very cooler. The fringes, what you are seeing, it's more like a bridge from Chennai to New York. If you put, it will be one of the smallest fringes here. So very beautiful umbra and penumbra you can see. Umbra is a dark region. Umbra in Latin it means dark. The outer region of the sunspot is called penumbra. There, John Evershed, he discovered there is a flow of gases from the penumbra of the sunspot to the umbra. And still now people honor them. To honor that his discovery, Government of India released a stamp for him. And straight away, we are going from here to the optical telescopes. Optical telescopes need the light, the star light. Sun is the nearest star, therefore, the light photons will be getting more here. But in the case of the stars, we need a bigger and bigger telescope because light is very, very feeble. The mirror, the telescope, what you are seeing is the called Vainu Observatory, VBT. It is located at the very close to Vaniyambadi. You can also make a visit there. In that telescope, the primary mirror size itself 4 tons. So huge telescope, and people are not so happy with the Vainu telescope. They wanted to put another telescope at Mount Himalayas, where the cloud cover will be minimum and the sky will be very clear. So that during the winter it will be shivering. It will be very, very cold. So this telescope remotely can be operated with the VSAT link. It can be remotely from, we can open the dome or the close the dome from sitting at from our Bangalore office. This telescope is giving very fantastic results and a very beautiful location, and this gives the results are being published in the leading science journals, and many of our scientists, they're using this Himalayan Chandra telescopes. Okay, this is the world highest observatory because any telescope you put it in the Mount Himalayas, it is the highest peak in the whole world. Therefore, this is the world highest observatory, 2 meters Chandra class telescope to be put. And we also very close to Bangalore, and we have the place called Gauri Bidinor, 30 to 150 megahertz. We work there, and we can make the image of the sun in the radio wavelengths. The image will be like this. And we are not stopped here, and we wanted to put in India, we wanted to put a space telescope. Space telescope is very, very difficult. More than around 15 years we worked to make a space telescope that is called AstroSat. It is still flying on the sky. The sky images, whatever we are getting, it's more better than the images from the NASA Galaxy satellite. It is very, very interesting. Please hide. Okay, sorry, hide. I'm sorry. Thank you. I think, can you see this one properly? I think people can give the feedback. I am seeing your feedback. I am listening to you. I am watching your feedback. Thank you. Wonderful. Okay. Here, Indian Institute of Astrophysics, has already told you, we have the Kodaikanal Solar Observatory, Vainu Observatory, Gauri Bidinor Radio Telescope, Himalayan Chandra Telescope, Hagar Telescope there at Mount Himalayas, and AstroSat. Very recently, this is our website. You can visit us at www. You can Google Indian Institute of Astrophysics. You can see that one. And space telescope now we are building is called Aditya. Aditya, will be next within one or 2 years. It will be flying in the sky. It will be giving a very fantastic images on the sun, very closer to the photosphere. 1.1 solar ODI onwards, we will be getting these images. These images will be very useful. It will be far better than the NASA's satellite now when if it is working. So the dynamic range is also expected. So it is very fantastic time resolution we are getting, and it's having that good dynamic ranges. Our Indian scientists are working, a group of people from our institute, and it will be launched very shortly. And if you wanted to go for any astronomical subjects, I would like to introduce few institutions in India. Abroad, lot of institutions are there. In Germany, we have the Max Planck Institutes are there. And America, it's filled with all the physics department is associated with astronomy department. Mathematics people also do a lot of astronomy. And Australia, they have a good facilities. France, all the countries around the globe, You can go for higher studies in any of these foreign nations. And India, Indians of Science is there. Aries, Aryabhatta Institute of Sciences, Earth Sciences is there. Nainital Cosmic Ray Laboratory in Tayapur, Physical Research Laboratory in Ahmedabad, and the giant meter wave radio telescope. Can you see this one? A small Armada Jeep is there. You can see it's really a giant meter wave radio telescope. They call it GMRT. It is very closer to Godot in Pune. Beautiful observations we can make it from here. That's working with the radio telescope. Radio frequencies, it's work with the meter wave. And Ayuka, most of you might have heard about it. Ayuka is doing a lot of promotion work, and it's propagating astronomy elsewhere. And they give young students and faculty members, like some of the faculty members, if you would like to are more interested to study astronomy, you can apply, and they will give you the to and fro and all the facilities they will give. And they will give you a lot of hands-on lectures, and they will give you the study materials to you. This is called Ayuka. It is very close to, it is near to Pune. And a lot of ISER institutes are there in many cities. And TAFR, they have a radio astronomy center at 327 megahertz. It's very nice location. And they use the technique called lunar occultation principle to study about the angular size of any radio sources. It is very interesting to, we can see they have evolved from the chart record days to very present day observations. They have modernized their telescope. 327 megahertz it is working. You can also visit our Kavalur Observatory. Let me start with some of the mysteries. It is me when I visited a NASA visitor center. You are seeing me just like holding a rock. It is more like a size of the jackfruit. Do you know what may be the weight of that one? Maybe any rock will be 10 kilogram or 15 kilogram or 20 kilograms. And for your surprise, I removed my watch and kept on that one. It's a meteorite stone. For your surprise, the weight is 160 kilograms. This is small size. The watch you are seeing that one. It's a small rock, but the weight is 160 kilograms. There starts mysteries. Like if you, the Cassini satellites, when it went very closer to Saturn, it found many number of satellites it has found. You can see that now it may be very difficult for you to see that one. I am just circling. This is the eclipsing picture of the Saturn. People have found it. And the invisible ring of Saturn also one can see that one. I don't know whether you can see it. The disk of the sun, it is seen, it is illuminated by the sunlight. Now you can see that the invisible ring of the Saturn. Okay, now let's come to Jupiter. If you see the Jupiter, if you keep very closer to the sun, it will be like that. The red spot in the giant red spot in the sun and Jupiter itself, it is the more bigger than the size of the sun, size of the Earth. You can see. You can put almost 1,000 Earth inside the Jupiter. The density of the Jupiter, though it looks like so much bigger, if you put it in our ocean, it will float. Meaning, the density is so less. Very interesting, am I right? It looks very bigger, giant planet, but the density is low. You put in our Earth, sea water or something, it will be floating like a ball. Good, very interesting. If you remove our Earth, Earth has a satellite's moon. If you remove our moon, nammude Nila. If you remove it, Nila, you put in the same place. If you put a Jupiter, Jupiter will look like this for you. If you are traveling on a road and if you look here, the Jupiter will look so huge, so bigger in size. Same, I am just replaced the moon place with the Jupiter. It will look so big in size for you. Am I right? The red spot is still a mystery. I am using the word mystery because it is not being properly understood. See, when you are taking any Earth rotation, you might have watched the cyclone. Am I right? Cyclone, when you are rotating around the equator, it is having the northern hemisphere and the southern hemisphere. When the cyclone comes, since the Earth is rotating like this, the cyclone will go and they will make a rotation like that, the hurricane. The other side, if you are seeing the southern hemisphere, it will be rotating like this because the Earth is rotating like in this fashion. But on the contrary, in the case of the Jupiter, the giant red spot is rotating in the anti-clockwise direction, which is not being properly understood. It is very bit difficult for us to understand in the Coriolis forces also. The Coriolis forces is bringing a rotation, but it is not in a proper way what we could see in the Earth atmosphere, but it is going in the, on the contrary, it is against our understanding. Therefore, I am telling this a mystery. Red spot and Coriolis force is a cyclone and what is responsible for the Earth, and constantly it is pumping. It is not very old. It is approximately around 150 years old. That's all the red spot. There are fresh colors are coming, and there is a volcano which is coming. It is not attached to the surface of the Jupiter, but it is almost 78 kilometers away from the Jupiter. See, when you see all these things, it looks very strange for you. Now you can see about the red spot. There are a lot of ripples are there, and the understanding the red spots itself, more than thousands of research paper have come. It is very very interesting to see that one. Can we see any other potential habitable exoplanet? Yes. Very recently, 2019, the discovery of the exoplanets, people have received a Nobel Prize, that you may be knowing that one. Let's take a Hubble Deep Sky View or a sky survey. Everywhere you see lot of galaxies are there. Anywhere. Galaxies or type of galaxies, it's a 6 months course. I just don't want to do it here in this forum. I just want to give a glimpse for you. Thus, all the stars what you are seeing now from our Earth, it is all belonging to Milky Way galaxy. Most of them from our Milky Way galaxy. But if you take the from our, if you move out of the our galaxy, then you can, Hubble has made a very beautiful pictures of deep sky view. There you can see about galaxies everywhere, plenty of galaxies, that we call that as a Hubble Deep Sky View surveys. Can we count the stars in the sky? Is it possible? Still, whether stars are being born? Yes, star forming regions are there. Still, stars are new stars are getting ready every single every era. We are getting a new stars, and the stars. If you compute the stars, and if you compute one star at a time, only 1 second, one star. How many stars within our own Milky Way galaxy? How many? If you count 1 second, one star, can you count it in 1 day? No. Can you count it in 1 week? No. Can you count it in 1 year? No. Can you count it in 10 years? 100 years? 500 years? 1,000 years? 2,000 years? 5,000 years? 1 second a star. 5,000. If you calculate, it will approximately take 12,400 years or so. We have 400 billion stars to 400 billion stars in our own Milky Way galaxy. All these things are belonging to our own Milky Way galaxy. So we have millions and billions of galaxies we have. Stellarium is a very good software. It is there in your mobile phone. You can use it in your mobile phone, or you can use it in your tab or something. You can download Stellarium. It's a very small price is there for that one. You can download, and if you move any particular direction on the sky, you can see that particular patch as, and you can very precisely calculate all this stuff. Very very interesting to do that one. Stellarium. The software name is called Stellarium. And if you take all the stars from all our ground-based observatories, all from the space-based observatories, if you keep all these things together, and if you put on a cube, we can call an observable cube. If you, from an observable cube, you take a small sugar cube size of the pieces and zoom it, then you will be getting a local superclusters. From the local superclusters, you will be see clusters of galaxies. All these things what you are seeing is a clusters of galaxies. You take only one speck of that one and just to zoom it to this level, you will be getting a Virgo supercluster where our Milky Way galaxy is there. If you still open it, zoom that small area, and if you zoom it, then you will be getting our Milky Way galaxy and Andromeda galaxy. Fine. Milky Way galaxy itself, we are 60,000 light year far away from the center of our galaxy. Center of galaxy, you all know that one. There is a very huge super sized, we have a supermassive black hole is there. We call that as Sagittarius A because it is there in the Sagittarius direction. So you can see that one so much. It is capable of, we are almost 60,000 light years. The light which is traveling for 1 year is called a light year. Most of you may be knowing, am I right? So where we are, 1977, Voyager 2, which is started going at a speed of 40,000 kilometer speed. Imagine if somebody driving your bike, you are sitting back for 200 kilometer speed, definitely you will be scared and you will say, oh, how speed it is. You are sitting in a bus, if it is going by 200 kilometer speed, you will be shattering. Am I right? But 40,000 kilometer speed started 1977. Now only it is reached the end of our solar system. Woods, cloud, and all the things are coming little later. Okay, so interstellar medium it is started entering, which is started at 1977. Started Voyager, going at a 40,000 kilometer speed. Just put your mind there. But if you put a light or laser beam towards the end of our galaxy, end of our solar system, it will reach within 500 minutes. That is the limit of our solar system, 500 minutes. But it is started 1977 started Voyager. Now only it has started reaching there. Just imagine now how far we are there from the center of our galaxy. Not 1 year, not 10 year, not 100 year, not 1000 year. We are 60,000 light year far away from the center of our galaxy. Our Milky Way galaxy itself, it is 100,000 light years width. I think it's all mind-boggling number. Am I right? We see all the stars in our stuff. It is 100 billion to 400 billion. Therefore, I told you it is. If you count one star at a time, it will take almost 2,400 years for you to do that. Very interesting. We are seeing plenty of galaxies. You go there, we have a plenty of galactic groups. Then we have lot of superclusters. Then local superclusters. Then we are coming to the observable universe. Universe is far bigger. Let me use the word. Our universe is far bigger than what you are imagining. It is so big in size. We have not reached anything like our understanding about our universe is very, very small. If you have any questions, I think I welcome students. Those who are watching, you can put your questions also on a thing so that time and again I am asking you to tell it so that I can answer your questions. Okay. So then Earth is insignificant. Earth is a small dot, speck of a dot in the entire universe. So this is our places. Almost 98% of entire solar system mass is concentrated on the sun. We all know that. And comets are formed in the Oort cloud. Then it will be coming around the sun, and it will be giving a good thing. The study about the comets itself, it will be so mysterious. It's very, very interesting. How old is our universe? If you ask a question, how old is our universe? Listen, it's very interesting. We could able to get the number almost 13.8. It is somewhere between 12 to 14 billion years ago. We could estimate the Big Bang happened or something. In Big Bang is a theory. It is from 1970s. It is there. It has been proved. We are going to see that one. We are Andrew Penzias and Robert Wilson. These two gentlemen, they tried to do a very good experiment about they got a Nobel Prize also for that. And the COBE experiment they did, and they made the map of asymmetry in the entire anisotropy in the entire universe. They could be able to identify. They could be able to do the calculation of almost 2.7 Kelvin. They could get everywhere, and they proved that one that is the starting point, or that is a proof for the expanding universe. I had a chance to go to this world biggest telescope, that is Arecibo. Now China has made a bigger telescope than this, and this is the small hanging around. This one on the top you are seeing, it's more like the size of the 4-story building. So if you see that one, some people are walking here. I think I took a photograph here. It's a huge telescope used to study about the pulsars and the interstellar medium and other stuff. And they sent huge. It is the size of the football ground. It's the size of this telescope to collect all this stuff. Andrew Penzias and Robert Wilson, 1978, they got a Nobel Prize for their observations on the millimeter wave waves associated with the so-called 3 degree, the otherwise 2.7 degree black body radiation. Black body curve, we all, you might have studied in the electromagnetic spectrum, you study about a Planck's curve, and it will be peaking around the yellow, which is the wavelength, which is the maximum peak of the sun. Our eyes also, which is tuned to the maximum wavelength, the sensitive wavelength is on the yellow side. So yeah, Earth is related to the humans, am I right? Sun is related to the humans. The maximum wavelength is also still coinciding with this man's eye power. And Robert Wilson and Andrew Penzias, they have made a very phenomenal experiment. In that one, they could calculate about cosmic microwave background, which is a building block, or that is the essential part to prove about the universe is expanding. Very interesting. Look, and let me take to the another great mystery, that is about the Jocelyn Bell. And along with his thesis supervisor, Anthony Huish, and she made a study and she was looking for the charts. And she found there was something is peaking and coming back with a periodical timing. That is the period is the small 1 second variation. If you take in your clock or watch clock, it is approximately 10 years or 12 years. You will be getting a variations of 1 second. That is the precision of a quartz watch. Here, the watch, the pulsar period, there will be a change in 1 second in 10 power 24 years. That much long time it will be so precise. The more better than the atomic clocks. Atomic clocks will be the time stability will be very precise. It will be going approximately 10 years or 12 years, 1 second variations to get it. But this pulsars will be 10 power 23 years. To that level of accuracy you will be getting from this rotating neutron star. The neutron stars are located though very far away, 8,000 light years. The Crab Nebula is approximately around 7,187 light years far away from us. The size is only 30 kilometers. The radius, the diameter of the neutron star is just a 30 kilometer, but it's located very far away. But still, it gives an intense imaging, intense radio pulses to you. When she was a graduate student, Jocelyn Bell used this telescope to observe this. And Radhakrishnan and Cook, they have modeled this pulsar, rotating pulsars. It has a very intense magnetic field, and when it is rotating, it gives the pulse. And the millisecond pulse has been discovered by very recent people here. And from some of our Indians are also involved in that one, in the discovery process. And 1969, Radhakrishnan and Cook, they have modeled, and still it is a very valid research paper, highly cited paper, one can say that one. Okay, if you if you remove your eyes are only sensitive to optical wavelengths. Listen, your optical wavelengths. You remove your eyes and fit you with the radio eyes, meaning you can see with your radio wavelengths, your eyes, the sky will be like this, what you are seeing in the picture. The Cygnus loops will be going, and the bright Cassiopeia, the supernova remnant will be there. It will be very fascinating to see the pulsars in the radio sky, and many other stuff with its late kind of the stars we can see from the radio astronomy. Radio astronomy is another window of the for observations. It is very interesting. This optically you can see nothing, but if you see from the radio images, if you see a central engine, very interesting. Am I right? The central engine, it is sending us two jets like a lobes kind of the stuff. It is sending the lobes here, but the central engine, it is called the central engine is very compact with a VLA, very large array in New Mexico in America. They have a huge telescopes, and they are using this radio astronomy principle to they have the aperture synthesis technique, they use it. Interestingly, they could make a map of this Cygnus, and optically you cannot see nothing for that one. Let me come to the very another mystery. Like 1950s, the general theory relativity became very popular. Einstein, when he was young, he formulated the Einstein's thing. In that one, you all know about curvature space and relativity. It's a very interesting subject in astronomy. Still, it is a very fascinating field in astronomy. And the general theory of relativity says about the curvature radiation, and it also says about the gravitational lensing. A huge mass or a very gravitating mass, if it is there, even the light waves can bend it. So it triggered the Sir Arthur Eddington, who was there in the Cambridge those days, and he and the Time magazine published after that one, and it is also says about the man who made Einstein very popular. He is nothing but this Arthur Eddington. Arthur Eddington, you also know that one. He is man behind the Chandrasekhar, and who was denied the theory for the white dwarf, that 1.4 solar mass. It has been found theoretically by Chandrasekhar. It is later days, people have not understood that one very longer period. Later they gave a Nobel Prize to Chandrasekhar. That's all part of the history, very history. And this man, he made Einstein very popular by his experiments. 1919, there was a solar eclipse happened in the in the sector from the Brazil to African continent. So he has sent a group of people. This is the experiment, and I don't know how many of you have seen a total solar eclipse. Total solar eclipse, the visible photosphere will be completely covered by the moon. Therefore, the outer layer, there is no way scattering light will be there to scatter the atmosphere. Therefore, the sky will look very dark, and you can, during the daytime, you can see the stars. If the sky is so clear without clouds, you can see the stars. And 6 months prior to that experiment, Sir Arthur Eddington, he made a very beautiful experiment. He calculated the positions of the stars. When sun is covered by the moon, then he identified it is apparently it will be bending. Can you see that one? The starlight, what you are seeing here, it is being bent by the presence of the gravitating thing, and electromagnetic wave, that is light wave, it is being bent. He has proved that one. It is a 1919 experiment. In a newspaper they have published that the one man who made a most famous measurements they have done that one during the time of solar eclipse. And this is the ingress and egress of the total solar eclipse. You will be getting the diamond ring. Most of you heard about it. And this is a very phenomenal experiment. In that one, Sir Arthur Eddington, he could prove that with the Einstein, that light waves are bending, and that is Einstein made very, very happy. And this is a very remarkable experiment. Okay, this is a famous experiment. A group of people from Cambridge and the Greenwich Observatory from England, they moved to Brazil and a part of the Western Africa, which I already told you. 29th May 1919 solar eclipse is a very remarkable experiment, and that proved the theory of special theory of relativity. Somebody asked somebody asked Sir Arthur Eddington, who the who has found, like they have asked him in 1990 in the interview, whether it is true that only 3 people in the whole world understood the general theory of general relativity. And immediately Arthur Eddington, jokingly or with a surpassing remark, he remarked, who is the third person? He asked, only 3 people could understand in the whole world could understand the theory of relativity. He said, who is the third person? He said, it seems. Okay, we have come to the detection of the gravitational waves. That was also very remarkable experiments in the September 14, 2015, and 9:15 UT, that twin laser system gravitational wave observatory LIGO detectors. One is at Livingston in Louisiana, another one is at Hanford in Washington, very closer to Washington. It's more like a Michelson interferometer. Most of you studied Michelson interferometer. That it will be having that one laser beam will be going, and it will be partially reflecting. The beam splitter will divide the beam into 2. One will go to the mirror M1 and reflect back, another will go to the mirror M2 and reflect back. Both the things will interfere with each other. Listen, it is very interesting experiment. And the laser beam will go even a small path length difference, that will make a fringe will be shifting. So when the gravitation waves cross through the earth, then it will be doing the density perturbations, meaning it will compress and rarefied. Then the wavelength, the path length of these arms will vary. Am I right? So your 4-kilometer arms, the mirrors were located. Let me show the picture for you so that you will understand it. Black holes will come back here, Hawking radiation. Okay, this is a very famous experiment, very closer to LIGO experiment in Washington. 25 kilometers it is there. This experiment, 4 kilometers length, it will be there. When the gravitational wave pass through the earth, it will compress the earth atmosphere, then it will shrink. Very small size, the size of the proton, 10 times more than the proton size, one can very precisely measure with this kind of the stuff, with this experiment. And they can also identify which portion of the earth it is going through. They have identified, and they also got a Nobel Prize for their very important discovery. And we'll go back to Hawking radiation and whether the black hole can give a rise to a radiation. And the theoretical physicist, you all know about Stephen Hawking, and he predicted there is a black hole called also emit a radiation that he called it as a Hawking radiation. And September 2010, he made a remark about his publications. Theoretically, with optical pulses, he tried to prove it, unable to do that one. However, the results are unverified even till date. Hawking radiations from the black hole, it's still a mystery only. And let's come to the very closing remarks by another very interesting studies. When the two black holes co-rotating with each other, the center of mass will be coming to a closer. Then finally, these two black holes will be fastly rotating and will collide with each other. When they collide with each other, then it will produce ripples in the space-time that can go through the millions and millions of distances through the galaxies. I mean, even if it pass through an Earth, it will produce a perturbation, meaning it produces a shrink, and it will be compressions, and that can be very precisely measured. And they have identified not only first black hole collision, one was around 54 solar mass, another one was around 60 solar mass. They could collide and that the energy was released, and they could identify the collapse of the two black holes. Not only once or twice or third time, they have made the remarkable discovery. In the fabric of space and time, they call the gravitational waves. Very interestingly, they have proved all this stuff, and a lot of theoretical works is also happening here in that one. Okay. Before going to the close, I just wanted to give an appeal to you, friends. And if you interest, astronomy is also a fascinating subject. Astronomy is a very interesting subject. Like, you will enjoy every single discoveries, and you will put all your mind and soul in the research. It is very, very interesting. CSIR, if you wanted to come for a research, you need to clear the CSIR net examination or a just examination. You can do that one. Even coming from an engineering background, you can join the research in astronomy. Many students, they are doing integrated MTech students are there with us. After your MSc, you can join astronomy stream, passing the GATE examination or UGC examinations, and you can apply for a joint entrance examination. Lot of institutions I have here in, I already shown you many institutions, Raman Research Institute, and already in the beginning of my lecture, I showed you about institutes. Ayuka, I have shown many other institutes, almost 40-50 research institutions are there. It is very interesting, and I know that you will, if you wanted to further your career in, you want to do it, and you can come to astronomy and astrophysics. Thank you so much. Thank you. Thank you. I stop here.
Yeah. Thank you, sir. Thank you so much for your informative presentation, sir. Sir?
Yes, I am here.
Yes. So there are some questions. Shall I post, sir?
Yes, please, please.
Yes. Dear participants, kindly post your questions in chat box so that Sir can answer. So this is a question by Muhammad Yashin Dawlat, who is active participant.
Okay.
Can you see that, sir? Or shall I read, sir?
Please, can you please read it?
Yes.
Oh,
How
Earth
can we
consists.
say that the density of Jupiter is very less and can float on water?
See, Yusuf Muhammad, you see, Yasin, it's a very interesting questions, and we can calculate from the very basic principles of the Newton principles. We can calculate the M1, M2, applying the gravitational constant and all the stuff. We can estimate the mass of Jupiter. Though it looks very, very bigger, volume of the Jupiter we can find it out, as well as we can find it out the mass. From that we can calculate very easily calculated. You just type it in a Google it, you will get a what's the density of the Jupiter. To put in your mind, I put that density of the Jupiter is less, so that it will float in a water. I gave a classical illustration to you so that it will register in your mind. Okay, when it is density is lesser, always it will float. Am I right? You can calculate what is the density of the Jupiter, what is the density of the water. Okay, thank you. Good. I think I am very happy that you will listen to the lecture.
Yes, sir. Next question, sir,
Okay.
by Jack Payne Clips.
Okay, Jack
Uh,
Queen,
yes, sir.
you can read it.
Is there possible for any planet to have a Earth's atmosphere for living?
So far, very interesting question, Jacqueline. So far, we have not found any planet like that. And potentially habitable planets, we say that on Kepler have found, Kepler is a satellite, we have found many satellites, approximately around 4,000 plus satellites we have found so far. It's very interesting to see that one. We are also looking for potentially habitable. If it is when we see a blue color light or green or something, we assume that is a water. And in an atmosphere, in my lecture, you would have seen that one. I would put almost more than something around 20 potentially habitable planets I have put from the various star system. It is all discovered by the Kepler. Kepler is a satellite being specially designed to discover new planets from the outer solar system. Yes.
So next question, sir.
Isai? Okay. Are we getting any signals from other galaxies? That's what the Arecibo Observatory, you remember, like I shown in my lecture. Arecibo's main objective is to send a broadcast signal to the outer space and to receive the signals. Very huge radio telescope. That's a very, very sensitive telescope. But they wanted to find out anywhere, is there anybody living? That is called SETI, searching for extraterrestrial intelligence. You might have heard about lot of movies, also English movies have come from aliens will be visiting all the stuff and all. So far we have not found anyone, and but we are not lost the hope. Still the search is continuing. People are wanted to study about more about extraterrestrial intelligence.
Thank you, sir. Next question, sir.
Yeah. Sonia Judith, sir, how that rock is 160 kilograms. I'm very happy. Like, what are the things I fascinatingly I showed you? It shows how careful you are attending to the lecture. It's very interesting. To my surprise, when I saw that one, I just like that. It is there in the NASA visiting center. It's if you have a very closer to Cuba, there is an island called San Juan in United States in Caribbean seas, and it's people speak Spanish there. They have kept a NASA. They have kept a science center. There only I went there. When I went there, I not stopped there. I wanted to, if you take a picture, you cannot, people won't believe. Therefore, I removed my watch and I kept on the top to take a picture. As well as I was, as if I am lifting it up, I took one selfie also with that picture. I'm telling about little, a few years back, I took that picture. I found that picture what they have on, that they put that one that it's a meteorite. It's a meteorite. It's you know Meteorite is heavy metals. It is not that the iron and all the stuff is there. It's a really surprise. People can do the chemistry with that one. It is a small size object like a palapalam. That is a jackfruit size object, but it's so weight. It is true. What's the reason? It's not the iron or some material. It's the new materials are there inside. Heavy metals are there inside.
Thank you, sir.
Okay.
Yes, sir. So next question, sir. Uh,
Same, Mohammed, you are asking another question. Sir, what is the any application to the gravitational wave? There is no application as such. Like, see, people wanted to find out what are the different. See, gravity waves that's not been proved till we discovered the collapse of the two black holes. It is not also in the sky. It is not happening every one day, single day. It is a rare event, rare of rare event. So people have waited for a long time. They have constructed the telescope or completely vacuum, 4 kilometers completely vacuum. You can imagine how big. Then, therefore, I urge you people to visit United States sometime. Or some of the experiments in Geneva also people are making large hadron collider and all. At least you take a time to read it. It is very, very, it is all beyond your mind. So big people have invested to discover about another one more lepton or one more muon. They want to find out one more elementary particle because dark matter and dark energy, if I am not touched upon the topic, that's also a mystery in astronomy. We know only 4% of the entire universe. The materials, whatever we are seeing, the materials or galaxies, if you put together, from the Big Bang, we could be able to get only 4%. Rest of the things are in the dark matter and dark energy. People have no idea about it. So they wanted to find about the missing links so that they can identify the new elements. So that is the reason for people are using the Large Hadron Collider. The gravitational waves is also it's a theoretical concept. People have in that mind. I remember 1919, Sir Arthur Eddington, along with team of people from Cambridge and UK, they went there to Brazil to study about the bending of the lights by the sun, solar eclipse. They also proved the existence of gravitational waves and many other applications. Like it's all applicable in theory of relativity. You can study about it.
sir,
Thank you.
can you answer some more questions, sir?
Yes, I can. I can.
Sir, sir, another question, sir.
Where and what are the institutions to study astronomy and astrophysics? In my slide also, I'm really thankful to you, Mohammed, and very happy for your thing. Indian of Astrophysics is the only institute in India we are giving if engineering graduates can come back to physics. Some of the students from Chennai, they study mechanical engineering, they're my electronics and electronics communication in the ECE and the EE department. They wanted to come back to science or physics, astronomy, and they are there now studying in astronomy. They are doing our integrated MTech and the PhD programs are there. We give a good number of scholarship, around 30,000 rupees. Even IT companies, they won't give you this much money. Am I right? Good. Then you can join astronomy, and it will be fulfilling your desires and your fulfilling your career also, and you will be having the bright future for your career if you have the astronomy. I have shown many institutions. You can also I will give my phone number and my email ID. If you are if you like, you can also contact me. Even with Dr. Krishnan also can help you.
Thank you, sir. Sure, sir. Sure, sir.
Yes.
And they can view in YouTube also. Thank you, sir.
Yes.
Yes, sir. So next question, sir.
Dr. Babu, what is the elemental composition of a rock? That is silica only, I think. Okay, I should ask this question. I should also tell some of the things I not fully covered astronomy, astrophysics topics. One of that one is people study about the star composition using the spectroscopy. Spectroscopy means you will know what is the element it's burning. If you use the spectrum of the sun, then you will know about what is the chemistry of the sun. From there only the thermonuclear reactions, all these things people have formulated. Hans Bethe in the year 1940s, late 40s, he got a Nobel Prize for that. That you may be knowing about the thermonuclear reactions which is happening in the sun atmosphere. Very this all this chemical composition, this all done by very easily done by our chemistry people here, very easily. I remember way back in the 1980s, I studied about taking a small rock sample to identify the Curie point in the rock sample. Then we can know about the composition. Then ferro component or metallic component and ferromagnetism to diamagnetism, transition with the temperature, all these things we can measure it. It's a very interesting. Anomaly University, they do this experiments. Still, they do that experiment. Thank
Thank you,
you.
sir. We are already running out of time, even though there are some interest questions. Shall I show, sir?
Yes, sir. Please go ahead. Oh, see, when you Mankala Rajeshwara Rao, it's very interesting question. How LHC, Large Hadron Collider experiment, discovered the God's particle? See, there's a very small documentary which is worth of a 15 minutes documentary. Is there? Please Google it and you can see that one. And they named as a God particle. God particle means then only they can the media and science supporters and funding agencies they'll give some money. You have to the inventor have the freedom to choose his own name. Like you can put if you discover a new particle, you can put any name as you like. The man who were the team they have put a God's particle because they thought that they can solve the missing link between the to solve the dark matter dark energy theory, but still a lot of things are missing. So you just Rajeshwar Rao, please see that one. I don't want to elaborate the answering session. There's a small less than 30 minutes presentation is there about LHC and it's very interesting. Please see that one. Thank you.
Sir, if you don't mind, shall we answer some more questions, sir?
Yes, please.
Yes.
Professor
Yes.
Venkata Rao, and is the bending due to diffraction? No, it's a gravitational lensing. The massive sun's massive gravitational body, gravitation waves, the presence of a gravitational wave is being proved. That's what I am telling about Sir Arthur Eddington's experiment. It's very phenomenal experiment. That is a very remarkable experiment. That made that's the way people say that one. That made Einstein very great, and that is the discovery. That is the way he proved that one, and he found that one. If you see that it's a gravity, every body is a gravitating body. That gravitating body can bend the light. If you take the light is going like this, you can bend it because of this gravitating body. That's I put in a cartoon. You would have seen that one, and it's not due to diffraction. It's a gravitational lensing. Thank
Thank you,
you.
sir. Thank you, sir. Sir, next question.
Kattu body, sir, what is the difference between black hole and white dwarfs? How we can find them in space, and what happens after the star comes to black hole or makes to the black hole? See, black hole is a supermassive or everywhere. In our own Milky Way galaxy, people have found almost 12 areas. You can see there is a vacuum and it will be there will be a circular kind of a stuff will be there because black hole will never allow even the radiation to escape out. It will absorb everything. It will pull it down because of its enormous gravity. So black hole cannot be photographed. That is even very recently days we have the pictures have come from the black hole pictures have come. You have seen the Horizon telescope, but the presence of the black hole can be felt. Even our center of galaxy, people know that one black hole. They have not exactly photographed or any stuff. They could be able to do it so far. The presence of the black hole can be felt. And white dwarf is totally different concept. Like Chandrasekhar put a limit for that one. It's 1.4 solar radii. That is stellar evolution. If you study the stellar evolution, then you can understand about the difference between that one. Black hole is a compact object, and the Schwarzschild radius and all the stuff will be there to define about the presence of the black hole, and they have calculated. in our own Milky Way galaxy, people have calculated or identified or photographed many missing pockets. They have identified it's a black hole.
Thank you, sir. Thank you, sir. The final question, sir.
Yes, thank you. Akan Shakar, what is the way to detect medium-sized black holes? Again, the black holes on the sky plane, we will be taking the different varieties of pictures. We can zoom to our diffraction limit, we can do the pictures, images, we can make it. With the help of the space telescope, people are making better pictures now. And we could identify there's a small black holes are there, around 12 black holes people find out. And mass also, by the nearby regions, we can calculate the star compositions and other stuff. We can calculate the mass of the black hole. So it is starting from 4 solar radii, 4 solar mass to that level. We have identified the black holes also.
Thank you, sir. Thank you so much, sir. There are so many questions, but we are running out of time. So, dear participants, if you are interested, you can contact sir. You can search in Google. Sir will answer. Thank you,
There are
sir.
many better people, professors are there in my institute. They work on a theory, general theory of relativity, and some people they work on a black hole itself. So I am working on the solar radio emission from the sun, but I can also answer your questions to the very limited way. But we have experts in our field; they can tell a very good answers for you, and you can also do if you are interested. You can see them in our website. Thank
Thank you,
you.
sir. Thank you so much, sir. Even in your busy schedule, accept me and presenting a lecture. As a part of this FTP, let me call Dr. K. Jayamurthy, Assistant Professor, to give a vote of thanks.
Thank you, Dr. Krishnan. Good afternoon to all. Saying thanks is more than good manners. It is good spirituality, as said by Alfred Painter. On behalf of our Department of Science, St. Joseph's College of Engineering, I take this great privilege to deliver the vote of thanks for the successful completion of the Day 2 Faculty Development Program on Recent Trend in Physics. First and foremost, we would like to render our many special thanks to our most respected Chairman, St. Joseph's Group of Institutions, Dr. B. Babu Manogaran sir, for his constant encouragement and providing a stimulating environment for such educational developments. I feel happy to offer my heartfelt thanks to Mrs. Jessipriya Madam, Managing Director, and Mr. B. Sasishekhar sir, Director, Dr. Vaddi Seshagiri Rao sir, Principal, and Dr. B. Barbadavadini Madam, Dean Research, for their support towards this event. From the depth of our hearts, we thank our invited speaker, Dr. E. Ebenezer Chellasamy, Head, Kodaikanal Solar Observatory, Indian Institute of Astrophysics, Kodaikanal, who has readily accepted our invitation and enlightened the session with this thoughtful lecture and active interaction. Really, he brings the universe in front of us. I am sure that his lecture will lead and motivate the aspiring astro researchers, which is the ultimate purpose of this online faculty development program. It is my burden duty to convey my thanks to our head of the department and convener of this faculty development program, Dr. V. N. Nandini Devi, who has been the driving force behind this whole process in all the phases on this event. I'm happy to express my heartfelt thanks to all the participants from the various parts of the world for your active participation and active interaction in this faculty development program. I owe my affectionate to my FDP team and my colleagues for their support and cooperation. Once again, thank you all. Dear participants, kindly join the last day faculty development program tomorrow at 11 a.m. Indian Standard Time. Thank you.
Thank you, sir. Thank you very much, sir. Dear participants, I have posted the feedback link in the chat box. It will be active in another 10 minutes. I will end the live now. So you can kindly fill the feedback link.
Thank you, sir. Thank you very much. Now you can
Thank you,
leave from
sir.
the
Thank you
meeting,
so
sir.
much, sir. Thank you so
Okay.
much, sir. Thank
Okay,
you
you
so
are
much.
most welcome.
Yes, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.
Dear participants, it's already posted in chat box. Kindly fill the feedback link. We can end the session in another 2 minutes.
Dear participants, a feedback link is posted in the chat box. Kindly fill the feedback link carefully. In another couple of minutes, we will end the session.